Hello everyone and welcome back. In this video, I want to talk about some inheritance, polymorphism, and object-oriented programming concepts based on Java to continue the previous video. So let's talk about inheritance. In this part, we will talk about is a relationship. Inheritance basically allows a new class, like subclass, to extend an existing class, which means superclass, inheriting its field and methods, and it represents a is-a relationship. For example, if we have a surgeon, it inherits from doctor, then surgeon is a doctor. But the subclass automatically has the variables and methods of the superclass, except the private ones, and can add new ones, override existing methods. Inheritance help promoting the code reuse, like common features, and establish a natural hierarchy. In this example, we have a surgeon, which is a doctor. We have a family doctor, which is also a doctor. But when you have a doctor, it doesn't mean they are necessarily surgeon or a family doctor, which is basically surgeon and family doctor inherited from the doctor. We have a is-a test, like the previous example. A surgeon is a doctor is not necessarily a surgeon. It's a good rule in inheritance to use this only if the subclass truly is a kind of the superclass. You can verify by plugging it into is a sentence and a surgeon is a doctor example. It makes sense. So a doctor is a surgeon. No, it doesn't necessarily mean that. It's a false. So it is a good way to test just to say is a. And when to use inheritance, we can use inheritance to model a clear hierarchy where a subclass extends a general concept with more specific details. Like inheritance is a great when you have an existing class and want to create a more specialized version of it. But do not just use inheritance to reuse the code where a relationship doesn't conceptually fit. The point is not just to use the same code, but to use the same idea, at least the same base. And then we will have a has a question, same as is a in the next slides. Overusing inheritance can lead to a fragile design if the hierarchy doesn't make logical sense. So this is what we need to focus on. And as I said, has a relationship is meaning a contrast to is a. It's called composition, means an object contains another object as a part of its state, has a relationship. For example, a car has an engine. So true. The composition is often referred for code reuse when inheritance doesn't semantically fit. A rule of thumb: first consider composition for sharing functionality. Use inheritance only if there is a clear is a relationship. Just because it has an engine, it doesn't mean it is kind of car. It can be a different thing. And so it is different to think about this. A constructor is a special method that is called when you use a new to instantiate an object. It has the same name as the class and no return type. And constructors are executed at object creation time to initialize the object state. If you use some C++, you also tried this. Java is similar to in that aspect. The constructors can be overloaded, meaning a class can have multiple constructors with different parameters list. Also the same like when you init a function in Python, also similar. The constructors can be overloaded, meaning a class can have multiple constructors with different parameter lists, allowing objects to be created in different ways. And this will answer what are overloaded constructors. Basically, constructs in the same class with different signatures. Here we have a car, and if you give it a string color in the same car class, one will come with construct with the color, other one will come as whatever the default is. So the constructor's execution order is like when you create an object of a subclass, constructors in the inheritance chain all run. First, the superclasses constructor executes the class where it came from. Then the subclasses constructor. Actually, Java ensures that before a subclass constructor runs, it automatically calls its superclass constructor. And then this happens recursively to the object. This makes sure that inherited parts of the object are initialized properly before the subclass adds its own initialization. So the subclass constructor can call the superclass constructor explicitly using the super syntax as the first line. If not, Java will call the non-argument super by default. And if a class extends A, then you do a new B. The sequence will comes from the A, that's the parent class. Then constructor runs, then the B will be running, which I will show some examples with VSCode. And the super is a keyword used to refer to the superclass. And using super inside the constructor calls the parent class's constructor. This must be the first statement in the constructor. You might use like super and give it parameters to call a specific superclass constructor. And if you don't call it explicitly, Java inserts the implicit super, like non-argument version. Besides constructors, you can also use super to access an overridden method or hidden field of the superclass from within the subclass, like super and some method, some function. In this example, like super hospital means it comes from the hospital, and there's a method called in the hospital called treat patient. So super.treat patient will invoke the base version of this method. Let's look at an example. Yes, we have doctor, surgeon, and family doctor. The doctor with one instance variable and one method, and it will have two subclasses, surgeon and family doctor. In the doctor class, it will have an instance variable of work at hospital, and method will be treat patient. Surgeon surgeon class extends the doctor class, and inherits like works at the hospital and treat patient. But it will override treat patient, and it will have a surgeon's way to treat that. It will have a new method, and we can call it make incision. It does not necessarily add a new instance variable. Family doctor, it will also extend the class doctor. It will also get the work at hospital. It will also get the treat patient. But it doesn't override treat patient because we don't have override. It adds a new instance variable called makes house calls plus a new method give advice. And I think this is a good way to understand what inherited and what is inherited. And using this scenario, we can answer questions like how many instance variables and methods does each subclass have? A doctor has one instance variable, one method is defined here. A surgeon inherits one instance variable from the doctor, treat patient, but it overrides it and it adds make incision. And so there's two methods available. It is on created make incision and overwritten treat patient. A family doctor also it inherits treat patient method and uses as is. Adds give advice method. So it has two methods and it also inherited the treat patient plus its own give advice. Also notice that any family doctor can perform treat patient because it's a doctor. It can access the doctor classes all methods, like once it has permission. But a family doctor cannot perform make incision. That's only under the surgeon class. A subclass only has its own methods plus what it comes from its ancestors, its parents. And then we have polymorphism, which means many forms. Literally, the translation means many forms. And in Java, it refers to the ability of single interface to represent different underlying forms, different types. The most common manifestation is a method overriding and dynamic method dispatch. This allows a subclass to be treated as a superclass type, but when overridden methods are called, the subclass's version executes. Here we have a doctor called doc. Doctor class doc object is equals to new surgeon, and doc.treat patient, it will call surgeon's method. Even if it's a doctor class, it will come from the surgeon. Before continuing with the polymorphism, I want to show some code examples for inheritance. We have doctor.java file. You will have a surgeon.java. We will have FamilyDoctor Java, and let's also have a main.java. So starting with doctor, I already created this part before the video, so I will just copy and paste. Here we have a public class called doctor, which inherited, and it has works at hospital, and as a default constructor, it will work in the hospital, and it will be general hospital string. And we have a method to be inherited or overridden, which is treat patient, and which says basically doctor treats patient. This is our doctor class. And now we will continue with surgeon. Here our surgeon has no new fields. It has a super, which belongs to the doctor, because it extends the doctor class. And we have an override function, the treat patient, which came from the doctor. And instead of saying doctor treats patient, it will say surgeon performs surgery on patient. And we have a new method, which calls make incision, and it will say surgeon makes an incision. If you go to the FamilyDoctor class, we have a new field this time, and it says makes house calls, which is a boolean, it will be true or false. And we have a public FamilyDoctor, which is super, which means calls doctor. And it's also makes house calls true. We are constructing the FamilyDoctor object. And we are inheriting the treat patient, and it's not overridden, and it's already coming from the super, from the doctor class, so we don't even need to say anything. But we have a new method called give advice, only for FamilyDoctor, and which says FamilyDoctor gives lifestyle advices. And in the main, to sum them all, we will be saying the first, let's call the doctor, then we will get the surgeon, then we will get the FamilyDoctor, then we will do some polymorphism just to show the demo. And let's compile this. Java, and we can say Java main. And then we look at the output. Let's start from the beginning. We have the doctor demo, and it says, okay, doctor treats patients. And if you look at the doctor classes method, it says doctor treats patient, which is true, and hospital is general hospital. Doctor works in the general hospital. And we go to surgeon. We are creating a new surgeon object called surgeon, and we have some methods. We can also access those, saying like surgeon and dot. Then when I say dot, it gets me the possible methods I can use, but we don't need it. We have treat patient method, which comes from the surgeon's inherited version. We have make incision method, which is only surgeon only, and it also has the hospital. We can also change it actually. If I can, hospital. Then we have a new hospital now. As you can see, we inherited the works at hospital string, but we change it here saying city hospital. When we go to FamilyDoctor, again, it comes from the doctor's treat patient, this first one. And in the FamilyDoctor, we have a FamilyDoctor special method, which is give advice. we give advice, makes FamilyDoctor gives lifestyle advices, which you can see here. Also, we can see if the doctor makes house calls, and as a default, it is true, and we didn't change it here, so it's true. And to show the polymorphism, again, we have doctor poly equals new surgeon. So basically, we are creating a doctor. We are calling the doctor class, but we are giving it we are calling it as a surgeon, which has some overwritten parts by the doctor. For example, here, treat patient, surgeon performs surgery, treat patient, doctor treats patient. So when we have polymorphism, if you are not sure which comes first, of course, you can just run it. But because Java knows this was the first created one, then this inherits from doctor, and this doctor calls again the surgeon. When we call treat patient, this time surgeon's override runs, and the output will be surgeon performs surgery on patient, not saying doctor treats patient. And if I were to uncomment this and try to compile, it will give me error because it is make incision is not coming from the doctor because it's a doctor type. It cannot see what it came from the surgeon, but it can get the overwritten parts. Here we are downcasting to call a subclass only method. First, we are asking the question if a poly is the instance of surgeon. If that's true, then we will be able to call surgeon casted poly, and then we can call make incision, but we cannot just say poly make incision. First, we need to typecast it, and that's how we get the output saying surgeon makes incision. That comes from the surgeon class. And as you can see, the last question is poly a family doctor? It is false because it is not a family doctor. And let's continue with the runtime method resolution or dynamic binding, which method implementation gets called is dedicated at runtime based on the actual object type, not the reference type. The Java virtual machine will look for the most specific override of the method, its actual objects class, and then call it. In other words, the lowest subclasses method wins in override situation. For example, we have animal, canine, wolf's method runs. Okay, here is an example. In inheritance chain, if animal is canine and wolf, if we all have like overridden, let's say we have a make noise function that comes from the animal, and we have canine, but we can skip it. And then we are saying, okay, let's create a wolf object from the wolf class, and it's a new wolf. And we have an animal, and it is wolf. If you call animal for the A make noise, then we will call wolves make noise. It will say whatever the wolf says, but not the animal noise. So it will inherit the latest lowest subclass method. So advantage of the polymorphism, basically it makes a code more flexible and extensible. You can write code that works with superclass or interface, and it will automatically work with another subclass implementations. Like for example, you could have a method that takes a doctor and type and calls it treat patient. You can pass the surgeon or a family doctor, and it will automatically use the appropriate behavior for that specific type. And this will reduce the need for if or else statements. And it will be type checking in your code that enables clean extensions and functionality by adding new subclasses without altering the existing code. And polymorphism combined with inheritance lets you adhere the open-closed principle and for open extensions or closed modifications. And when you have superclass reference to a subclass object like doctor doc equals new surgeon, you can only call methods that are declared in the doctor class, like I showed in the example. The compile time type also. If you need a call to subclass specific method like make incision, which only has on the surgeon, then you must downcast the reference back to the surgeon. Like here, surgeon doc make incision, and downcasting should be done with caution. You should be sure that object is actually that subclass type. Otherwise, you will have a class cast exception error, which is runtime error. And upcasting it, like casting a subclass to a superclass type, is a implicit and safe because you are restricting to a more general interface. And downcasting is explicit and can fail if wrong, and just like we showed in the examples, which is here. If I run it, it gives me compile error, not in Doctor, but when I downcast it, it can access the make incision method from the surgeon. And we have method overriding and overloading. Overriding a method means a subclass provides a new implementation for a method that it inherits from a superclass. The method signature and like name and parameter types must match exactly the superclass version. Overriding is used for runtime polymorphism to change or extend base class behavior in the subclass. For example, when we go back, the class animal has a method called makeSound, and class dog extends the animal, overrides makeSound to bark instead of the default sound. When you call makeSound on an animal reference that points to a dog, dog's override executes. So overloading means creating another method with the same name but different parameter list and or return type in the same class or sometimes in a subclass. Overloading is not about polymorphism. It's to resolve at compile time, and the compiler will choose the correct method version based on the argument types. Overloading is used for convenience, allowing methods that do similar things accept different kinds of parameters. I actually showed some functions before. Maybe in the Redis server, we did some overloading for some. It was maybe assembly. I don't remember. And yeah, overloading is used for convenience, allowing methods that do similar things to accept different kinds of parameters. For example, when you have like add method, like we discussed before, and it gets like, it might get string or integer as numbers, and it can do the adding together. You can put the parameters as like integers, but they can also come in the string or float or double. So it makes sense to overload sometimes because they have similar functions anyway. And there's also another example. You might overload a constructor or method like print to accept different types of data. To summarize, override means runtime decision. Subclass changes the behavior of inherited method. Overload means compile time decision, or same class or subclass provides multiple method signatures for different input scenarios. An abstract class in Java is a class that cannot be instantiated. Basically, you cannot directly create objects on it. It means it's meant to be extended by other classes. It often represents a generic or base concept that is too incomplete on its own. An abstract class can include abstract methods like with no implementation, like nobody, just signature ending in semicolons. And any subclass of an abstract class must implement all its abstract methods. Here we have an abstract class animal, but I will show this example, which is better. You can see abstract class animal, which has methods called makeSound and eat. So eat already has a body, so you don't need to declare body when you call duck as an extension of animal. But for makeSound, you need to override it, and you need to put whatever that animal specifically says. In this case, it's a dog, so we just said woof. And so abstract basically means you need to fix it to work, but it can work for a lot of animals. We use it when abstract class have a base class that should provide some common implementation of definitions of subclasses. but you don't want anyone making direct object of the base class. It allows you to define a template and maybe including some implemented methods and some abstract ones that's for subclasses to customize behavior. You can also go deeper, like you can have abstract class of animal, then mammals, then canines, then dogs, then you can go deeper and deeper. But like I said in this example, all you need is like override some methods and you can use the abstract classes. And next up we have interfaces. In Java, it's a pure abstract type that defines a set of abstract methods, which is new in Java. In the newer Java versions, we are allowing default and static methods with implementations, but in the context of basics, think this as a contract of methods with nobody. A class that implements an interface agrees to provide concrete implementations for all of its abstract methods, and interfaces are used to specify a common capability or role that can be adopted by otherwise unrelated classes. Here, the concept is like what actions can be done without specifying how they are done. For example, you might have an interface called drawable, which has a method called draw. And in different classes like circle, rectangle, triangle, you can implement drawable, and each will tell how to use it in its own way. And for example, we have the void draw, but there's no function body, and here we are declaring drawing circle. And we don't even use like override or anything. This allows us to use polymorphism. You can treat all drawable objects as the same call, just calling draw, without knowing the exact class. And it also allows you to have multiple implementation. And the key difference from classes is that a class can implement multiple interfaces, but can extend only one class. And this is useful for adding common behaviors to classes that don't share the parent class, not inherited. If we have something like printer, it can implement both serializable or runnable interfaces to indicate it can serialized and run in a thread, respectively. We don't need to look more in this example. This example shows what I was thinking. Void draw is like the implicitly public abstract here. And when you call class circle, which implements the drawable, you can override the function, not override, but interface the function. And you can just show how short interface and a class implementation is coded for exams, or like you can just give this simple example. Okay, so abstract class and interface, let's summarize it. Both abstract classes and interfaces allow you to define abstract methods that must be implemented by subclasses. Use an abstract class when you have a base class that should carry some default behavior or state. And use interfaces to define roles or capabilities that can cut across different class hierarchies. In the early Java versions, interfaces were the only way. But now with default methods, interfaces can have some implementations, but they still can't hold state like instance variables. The exam might simply ask to describe what an interface is and give an example, which we already did. Just focus on like all methods in interface are abstract. Classes implement interfaces, and multiple interfaces can implement it by one class. So this was all for this video, and in the next one we will continue with exception handling and garbage collection. And in this video we talk about inheritance, saying like surgeon is a doctor. We have composition. The car has an engine. We talk about constructors and super. Constructors like when you declare something beginning of the file, and super comes from the parent class. We get doctor example. We talked about polymorphism. We showed examples, and we talked about casting and method resolution. We casted the doctor to lower class surgeon. It doesn't sound right, but in Java at least. And we talked about abstract classes and interfaces. So thank you for watching this part, and see you in the next one.